Hello everyone, welcome to Augmented Technology Private Limited. Today I am excited to introduce our one of the product, that is 4DOAOM. It's an 4-channel digital output, 4-channel analog output communicating with the Modbus, that is RS485. Here we have the model. In this model, here we have the power supply connection. For this power supply, we have the configuration as positive and negative, where you can connect up to 24 volt DC in any direction. For this board, we have used the bridge rectifier, where it connect the reverse connection also for the board. And here we have the RS485 for the communication. So here we have the configuration as A for the positive, B for the negative, where we can connect with the RS485 cable to the PC to get the data. And here we have the dip switch part. In this dip switch, where user can set their own slave ID and the baud rates. For the baud rates, we have already mentioned in the board. For slave ID, where user can set up to 15 slave ID. And here we have the DO part, that is operated through the relays, where you can connect with the relays, switches, motors. And here we have the EO part. Okay, for this EO we have the jumper provision, that is for 10-bit and 12-bit provision. So just by shifting the jumpers, we can set the analog output provision as the 10-bit and as the 12-bit. And here we have the reset button. Whenever we are changing the baud rate and the slave IDs, on that time we need to just press the reset once. So the board will get configured with the new slave ID and the baud rates. For the next step, we will focus on the testing process. Please concentrate on the testing procedure and ignore the board visuals which is provided in the video. In this video, we will only know about how to connect the power supply and how to connect the RS485 with the Modbus cable. Okay, here we have the power supply part. There we have mentioned in the board, that is positive and negative. Connect the power supply with the positive and the negative and provide the power supply. See here the LED turn on, that means power supply has provided properly. Then get to know how to connect the RS485 cable. Here we have provided the configuration as the B, that is for negative. Here I have connected the negative. A for the positive, I have connected the positive wire. So then connect this wire with the PC. Okay, this is the RS485 cable. So I am connecting this with the PC. Now we will connect the RS485 cable with the PC. So I have connected with the PC. Now open the device manager. In the device manager, go to the port here, that is showing as the COM6. That means I am using the port number 6 for the serial communication. So then go to the Modbus pole, click on connection, connect the board and select the port and click on OK. See, the board has connected properly. After proper connections, here you will get the RX and TX LED blinking continuously. That means RS485 communicating with the PC properly. In this video part, we will get to know how to configure the slave IDs and the baud rates. So here we have the slave ID and the baud rates. So by default, that is the 9600 baud rate and the slave ID will be a 1. So now we will go with the PC. See here the board has connected properly with the default baud rate and the slave IDs. So now I need to change the slave ID as the 3. Okay, before changing the slave IDs, here this is the dip switch for the slave ID. So here in the dip switch they have mentioned 1, 2, 3, 4. That means the slave ID configuration as the 1, 2, 4, 8. That means if I need the slave ID 3, then I need to hide first and the second pin. That means 1 plus 2, that will be a 3 slave IDs. Okay, then I need the baud rate as a 19200. So the first pin that is mentioned in the board, that is 19200. So I will hide this pin. Now I need to press the reset. So the board will get for the new configuration. See here I will get the timeout error. Whenever you will get the timeout error, disconnect the board and connect the board with the new configuration. The baud rate as 19200 and the slave ID will be a 3. Okay, see, after connecting this, Here the TX has continuous increasing. That means the board has connected with the new slave ID and the baud rate. So now I need to set the slave ID as the 5 and the baud rate will be a 38400. So now I will hide the first pin slave ID and the third pin slave ID. That means 4 plus 1, that will be a 5. Now I will need to set the baud rate, that is 38400. That is the second pin. So I will hide this pin and now I will press the reset. See, here I will get the timeout error. Do the same thing, disconnect the board and connect the board with the new configuration. The baud rate will be a 38400. Okay, then the slave ID will be a 5. See, here the board has connected properly with the new configurations as a slave ID 5 and the baud rate 38400. So now I need to set the baud rate as the 57600 and the slave ID will be a 15. So if I need the slave ID as the 15, then I need to hide the all slave ID pins. That will be a 15. Okay. Now I need to set the baud rate, that is for the 57600. Okay. Now I need to press the reset button. Here I will get the timeout error. Then disconnect the board and connect the board with the new baud rate and the slave ID. Here the baud rate 57600 and the slave ID will be a 15. See, the board has connected properly with the new slave ID and the baud rate. Now I need to set the slave ID as the same and the new baud rate, that is 15200. See, okay, 15200, that is the new baud rate. Just press the reset, disconnect the board and connect the board with the new baud rate, that is 15200. Click OK. See, the board has connected properly because I have put the slave ID 15 as same and the only change, that is baud rate. Now I need to get back all these with the default. So load the all pins. Okay, otherwise you can set only first pin as a high for the slave ID, otherwise you can low, there is no issue. Now press the reset. The board has gone for the default slave ID and the baud rate. So now here I will get the timeout error. Disconnect the board and connect the board with the default address. Baud rate is a 9600 and the slave ID will be a 1. See, the board is communicating with the properly for the default addresses. Open the Modbus and click on connection. Connect the board with the port number with the serial port. Okay, and the all baud rate and the everything will be default. Click on OK. See, here the board connected properly. Here you will get the RX and TX LED blinking with continuously. That means the RS485 communicating proper with the board. Now for the according to the datasheet, the first register will be a DO part. Okay, here we have the 4DO. The starting 4 register will be a DO part, and click on that, provide the value as the high and send the request. Within the second, the LED has turned on. That means the DO1 operated properly. And do the same thing for the DO2. Click on that and provide the value on, send the request. Here the DO2 has operated properly. Do the same thing for the DO3. Click on that and provide the value as the high. Then the DO3 operated properly. And click on the fourth DO, provide the value as the high and send the request. The DO4 has operated properly. That means the all DO has operating properly. There is no issue with the DO. In this part, we will get to know how to configure the analog output. For the analog output, we need one multimeter to check the voltage. So here I have the multimeter. So the board has connected properly. So now here in this board for analog, we have the 10-bit and 12-bit provision. By currently the board is in 10-bit. Okay, for the 10-bit, there is the Modbus register will be starting 4 register will be a 10-bit. according to the board and according to the data sheet you will get the mentioned register in the whatever the analog output is there. According to that resolution you will get the mentioned registers in the data sheet. So according to that data sheet you will get the values. So for this board, for the first 4 means 1 2 3 4 is the 10 bit for the analog output, and 5 6 7 8 is for the 12 bit analog output resolution. So first I will check with the 10 bit. So for 10 bit here I will provide the 1023, that is a 10 bit resolution. So whenever I provide that 1023, so for the first EO I will get the voltage. So here I will check the voltage. See, for the EO1 I am getting the voltage as 8.14, that means full resolution. So for the here for second I will provide a 512, that means a half resolution. So in EO2 I will get the 4.1 something, that means it's a 10 bit. I provided the value as 512 resolution, that means I will get the half voltage near 5 volt. And for example now for the EO2 I will provide 1023, so I will get a 8.2, 8.19 or 8.2 something. So according same for EO3 I will provide a 700. So I will check with the EO3. So I am getting the 5.5 voltage, and do with the same for the EO4. I will provide 800. So for EO4 I am getting 6.3 something for the 800 resolution. It's all about for 10 bit resolution. So now I will shift the jumper to the 12 bit. So for 12 bit we have the mentioned register, that is 5 6 7 8. In 5 for AO1, so for AO1 it's a 12 bit resolution, so I will provide 4092. For the AO1 I will get a full voltage, that is 8.58. So if I provide here as a 202023, so I will get a half, that is 4.8 or 5 voltage, because it's a 12 bit resolution. So for 12 bit resolution we have the 4095. For I have provided the 2023, that means I will get the near to 5 voltage. So for AO2 I will provide a 4093. So in AO2 I will get 8.58. okay. So in AO3 I will provide 1023. So in AO3 you will get a 2.47. In EO4 I will provide 4095. So I will get the full resolution value, that is 8.58. okay. So it shows the all AO part is working properly.